Alright, so in this video, I'm going to solve the equation x to the power of 8 is equal to 25 squared. So to solve this, I'm going to first rewrite this as x to the power of 4 times 2 is equal to 25 squared. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2, and this is equal to 25 squared. Now I'm going to subtract 25 squared on both sides. So these two cancel out, and I get x to the power of 4 to the power of 2 minus 25 to the power of 2 is equal to 0. And before we actually do this, I'm actually going to take the square root on both sides so I can cancel these 2's out. So I get x to the power of 4 minus 25 is equal to 0. Now from here, I'm going to rewrite this as x squared to the power of 2 minus 5 squared is equal to 0. So now I can use the formula a squared minus b squared is equal to a plus b times a minus b on this. So this turns into x squared plus 5 times x squared minus 5 is equal to 0. So I get two equations. X squared plus 5 equals 0, and x squared minus 5 equals 0. So for x squared minus 5 equals 0, I get x squared equals 5. If I take the square root on both sides, I get x is equal to positive or negative square root of 5. Now for x squared plus 5 equals 0, I can subtract 5 on both sides. So I get x squared is equal to negative 5. If I take the square root, I get x is equal to the square root of negative 5, which is equal to the square root of 5i. So these are my four solutions to this equation. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2, and I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4,000 and b is 96. So this turns into 4,000 squared plus 2 times 4,000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry. All of this times 2 minus 1. Now, 4,000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.